Alright, so in this video, this is the specifics of peak picking and duplicate removal, and I can probably add on to here starting with highest peak. So we're going to get into the details of how to do those sorts of things algorithm-wise, and if we get a chance, maybe we'll try our hand at a little bit of Fortran. But let's, before we get into that specific level of detail, let's give the overview of this part of the project, and then we'll do like a pseudocode kind of stepwise thing, and then we can get into the particular syntax. So here I've got our pothole history again, our file 1. And what I've done to make this a little bit easier to work with is I gave each of these a line number, 1, 2, 3, 4, 5, whatever, and this is the value. So this is the point in time, whatever time unit that is, and this is the axis here, say microstrain, if that's what it is. Alright, so the first thing we're going to do, what I always recommend to do first, is to find your peak and rearrange the time history. Alright, you can do this directly in Fortran, but you can also kind of see, and I can illustrate this in Excel. So let's find the maximum value. Oops, need my little @ symbol there, of column F, and that value is 6576. So if you can see that, maybe I can zoom in on this a little bit. So what we can do is we can find this 6576, and we're going to cheat a little bit since we have this open in Excel. If I hover over that, it looks like it's at around 1095. So I'm going to come down here to 1095, and there's our value. And that's actually a repeated value right there. Let's just start with the first one. Okay, so I'm going to take this and everything down. Now if you do a shift and end down arrow, it should get us down to the bottom of that column, and I'm going to cut this and I'm going to paste it into this column, and now I'm going to go to the bottom. Oops, if I go end up, it'll get me to that one, and I'm going to shift end up, and I get here. I'm going to cut that away. I'm going to go down to the bottom of this one, and then I'm going to paste it in here. Okay, so let's see what our original picture looks like. We just got rid of all of our values. So I'm going to copy and I'm going to paste this here. Okay, so that's our original picture. And now let's make a copy of this. Get into select data, and instead of F, I'm going to use G. Okay, so this is what I mean by rearranging our time history to start and end with the highest peak. And actually, let's check. I need to end it with the value of 6576. So I'm going to take this point right here and I'm going to paste it right here. This will be a 7783. Let's select our data again, and now we'll go to 83. So now we should start with that highest value, and now if I get hovered over it, we're ending with that same highest value. Alright, so find the peak and rearrange the time history. So let's be a little more specific. Let's erase that. No, that's fine. Find the peak and rearrange the time history. Let's add to this to start and end with the highest peak. And the reason why we're doing this is for a standard rainfall cycle counting algorithm. You can also do the lowest valley, but for our class I want you to do the highest peak, and there's reasons for doing the highest peak that we'll discuss in class. Okay. And this can all be done algorithmically. You don't have to cut and paste this in Excel. Now one thing you'll notice is that you see we have this kind of a jump right here. That can happen. And that's real. That's a real artifact of maybe some plastic deformation that happened during this event. But we do need to keep that track of that. We do need to keep that. All right. Now the next thing we're going to do, now that we have the rearranged history, so we're going to operate on the rearrange time history. We're going to first remove duplicates and find peaks and valleys. Alright, so I'll bring this back over. Let's look at the very start of our time history. We have these values: 6576, 6576, 6529, and 6424. So we know we started with a peak. And we happen to have a duplicate point. And then it drops a little bit. And then it drops a little bit more. So if we were connecting the dots on this, it would do something like this. If we were to zoom in our picture now, maybe the slope between here and here isn't quite right. Maybe it's steeper on one part, but you get the idea. So how do we identify whether or not we've got a peak? How do we identify whether we not have a duplicate point? Okay, so what we're going to do is we're going to read in 3 points at a time. And for our purposes, I'm going to call them A, B, and C. And we have to be kind of careful. So we're going to read in A, and then we're going to read in B. And then we're going to have a statement that's something like, if A is equal to B, then we're going to redo the read-in of B. Okay, so we're going to shoot it back there. So this algorithm would start off reading 6576 for A, 6576 for B. Okay, well, okay, this is true, so then we jump back up to here, and now we're going to read in this point as B. Okay, so A stays that value, B was a duplicate, So this isn't exactly C, this is our real B point. Alright, so we had a duplicate 6576. So now our algorithm says this is point B, and then we read in this point C. Okay, so now we have 3 unique points, A, B, and C. Let me save this. And we'll make a little bit of room. Well, in general, we need to think about how can we identify whether or not something is a peak or a valley. And if we've gotten rid of the duplicates, there's really only 3 things, I guess, that can happen. We can have a point here, a point here, and a point here. We could have a point like this, or we could do something like this. I suppose we could have 4 if we have points that go like this. All right, so obviously the 2 cases on the outside edges are cases where we do not have a peak in the middle. So each time this is A, B, and C. All right. Okay, B is not a peak, B is not a peak. And these 2 in the middle, B is a valley and B is a peak. Now when I see peaks, I usually mean peaks and valleys. When I see peak picking, we're actually picking peaks and valleys. But I guess we can be specific here. B is a valley, and here B is a peak. And without knowing what the numbers are for A, B, and C, one thing we can tell is that the slopes are definitely different. So we have the slope A to B that we can calculate. We have the slope B to C that we can calculate. And if slope AB is different than slope BC, then we want to retain the point B. If the slope A B is equal to the slope BC, like we have in the case on the left and the right, then B is not a peak. Let's save this. Make a little room. Okay, so we've calculated those here. We have this step where we check the slopes. At this point, if we do have a peak or valley condition, this needs to disappear. We have to take our point C, we have to get rid of our point A. Our new point B is equal to, let's see, our new point A is equal to old point B. Okay, so A would be equal to B. Point B would be equal to our old C. And then we would read in a new point C. So then we would go back up to here where we read in point C. Now if on the other hand, if slope AB is equal to slope BC, okay, point B is not a peak, like we have in this case, then our point A stays the same. Now, this statement would not have to be in your code, but just for keeping it straight right now in the algorithm, our new A would be the same as our old A. Our new point B would be our old C, and then we would read in a new C. So we've identified a peak or valley, and we would keep that. And so we would process this until the end of the file. So let's put here process this until end of file. Now there's different ways to find the end of a file. There are end of file functions in some programs. You may just have to say we have 7,732 points in this file. So we do this that many times and then we're done. All right, so that's the main algorithm. Now for the Fortran specifics, I'm going to save that for later in case we have some specific questions about the syntax. If nobody's going to use Fortran in the class, I'm not going to get into those details. But I think you can kind of see how this goes. So one of the things I want to emphasize about programming for this kind of thing is there's nothing fuzzy about these things. These are very deterministic type programs. You got to do this, and you got to do this, and you got to do this in the right order. All right, so I think that's enough on the peak and valley determination. If you can do this within the first week, 2 weeks of class, then I think you're going to be in good shape for the rest.